Alright, welcome back. We're going to go ahead and take a look at graphing of systems of inequalities. For this particular video, I'm going to be flipping back and forth between Desmos and this notes packet so you can see. You'll notice I've also removed the graphs from my notes page so I can concentrate on solving for y in each of these cases. So what I want to do is I want to address this situation one at a time. You're still going to graph on your paper, just make some space for y equals off to the side or on a separate piece of paper as you go. Alright, here we go. Question number 1. Notice that in both of these cases I need to solve for y. So in my first equation, I went ahead and just simply moved the 2x to the other side, giving me this equation, and I simply moved the x and divided by 2 to give me the second equation. If you're having difficulty getting these solutions, please let me know, because it's important that we're getting the algebra correct when solving this. The answer to number 1 looks like this. You'll notice because both are equal to, both are solid lines. You'll notice also that the solution to this system of equations or inequalities is located where the red and the blue meet, making purple. A solution to this particular problem is any value within the double shaded region, including any point within or on either of the two lines. Since they're both solid, they are both included. Question number 2. You'll notice that y is less than 3 is not something we need to manipulate. We're simply going to solve the second inequality for y, and gives you that result. The horizontal line is dotted. The diagonal line is also dotted. The only difference between this and the other solution set is that any point contained within the double shaded region is included. However, any point on the dotted line is excluded. Question number 3. In this particular problem, you'll notice that you have two identical equations with switched inequality symbols. So that's going to give us a single identical line, and on one side you'll see the shading is above, and on the other side you'll see the shading is below. Notice one dotted line and one solid line. Now let's take a look at this so you guys can understand graphically what's going on. So notice here, question number 3 is set in place. You'll see here that if we can take away the purple line for a second, that you have a dotted line for the inequality that is not equal to. You'll have a solid line which covers that dotted line. And now you'll notice the shading goes below on one and above on the other. However, there is no overlapping area of shadedness, so this solution is no solution, because there is no place where both the orange and the purple overlap. Even the line itself is only true in one of the solutions, not both. Please make sure that you're taking the time to actually graph these. You should be pausing the video to match your graphs to what I'm doing each time. Don't just rush through this and miss out on these graphs. Make sure you're doing it to get the full effect of this particular exercise. Solving this first equation is simple, okay? However, solving the second inequality is a little bit more tricky. It is only tricky because you have to remember a specific rule of algebra. That is, if you multiply or divide by a negative number, you must switch the inequality symbol. Please pay particular attention to this, because it is going to be something that you're going to encounter in the future, and you're going to need to do it properly in order to get your correct solutions. You'll notice your solution set is here. and I've picked that value for it. Question number 5. Y is greater than 5. Nothing we need to manipulate here. And once again, we're dividing by a negative number. By dividing by a negative number, you must remember to switch your inequality symbols. Always, always, always. The final question that there's no need to do any manipulation for. It's simply ready to be put into graphic form. And there is your solution set, the double shaded region with your solution highlighted there. All right, that's going to lead us on to our next particular portion of the assignment. And what we're going to look at here is we're going to look at how to write equations based on the fact that you're given a graph. Okay, so the first thing I'm going to do is I'm going to address the y-intercept and the slope of each of these lines, with one of your y-intercepts being at +3, the other one being at -3. The next thing I'm going to address are the slopes of these two particular lines. I go up 2 over 1 to get back onto this one. I have to line up my y-intercept, and that's going to give me a +2. Next thing I'm going to do is I'm going to find this one. Down 1 over 1 gives me a slope of -x here. Now what I've got to do is I've got to figure out which side of the line is in the solution set. So the dotted line, if I point up, that's greater than. If I point down, that's less than. What is above is shaded. Therefore, it's going to state y is greater than the line 2x minus 3. I know that I do not need to put an equal to here because the line is dotted. Likewise, I'm going to come over here, I'm going to draw my arrow up, I'm going to draw my arrow down. The arrow that is pointing up is within the shaded region, so I'm going to use the same inequality symbol here. Y is greater than or equal to is your solution to this particular problem. And that would be how you would write your solution or your inequalities for any given graph. The next thing we're going to look at is we're going to preview a little bit of linear programming. Linear programming is a very useful tool for people who are in business. Business needs to work at a very optimum rate, which means that there cannot be any waste. If you waste money, you're out of business. So this is a way for you to utilize this to help you streamline your business more effectively when you get out into the real world. So we're going to write a couple of equations here talking about this person's mowing and raking leaves job. All right? So we'll go ahead and write our first equation as 12x plus 6y must be greater than or equal to $120 because he wants to earn at least $120 per week. We're also going to look at his time constraints because he's restricted to working less than 15 hours a week. So we've got to make sure that we understand how these inequalities look based on the words that are written in our particular problems. So please pay attention to those very specifically. This one is very simple. I'm just going to move the x, and I get y is less than or equal to -x plus 15. The second one, that one's a little bit more tricky, got a couple of steps there. So it's going to be 6y is greater than or equal to -12x plus 120. Dividing both sides by 6 is going to give me my equation that I will use. Y is greater than or equal to -2x plus 60. Sorry. Let's try that again, shall we? Plus 20. Alright, first thing I'm going to do is I'm going to come up here to 15. If I have a slope of 1 to 1, that means this thing's going all the way down to 15, and I will graph my line like so. Alright, next thing I'm going to do is I'm going to go up here to 20. If I've got a slope of -2, that means that I'll get down to -10 when I cross the y-axis. So I'll connect those two lines to each other right there. Notice also that I've got a feasible region, that's what they call it in linear programming, a feasible region which must be greater than the first line but less than the second line. Therefore, my feasible region is located here, in this area right here. Sorry for the overflow. Whoops, that's not what I wanted. Let's get that more. Okay, you can see what I mean by making sure that it's inside the feasible region. Alright, if Jamal decides to mow for 11 hours, what's the maximum number of hours that he could rake? Alright, so we're going to mow for 11 hours. Let's get the right pen. We're going to mow for 11 hours, so that means he can make a maximum of 4 hours of raking. Alright, if he decides to rake for 6 hours, alright, let's go up here to 6, and if I go over here, the maximum number of hours and the minimum number of hours are here and here, and it's this time that they ask for the minimum number, which is going to be 7 hours of mowing. Alright, question number 9. What I want you to do here is I want you to pause the video. I want you to work through this particular problem on your own, and I want to see if it's something that you can come up with the solution to before you do the work. Tomorrow, at the beginning of class, for a warm-up, we are going to discuss question number 9 and make sure everybody has the solution before we move on with systems of equations. Please take the time now to answer these problems so that you can get a full grasp of linear programming.